Hi, I'm going to finish up a couple notes from section 8.1 here. In particular, I just mentioned the shifting theorem at the very end of class last time, so I wanted to go through the proof of that and give one example. It's a very important theorem. We'll use it quite a bit when we're finding inverse Laplace transforms. So here's our definition of the Laplace transform of a little function f. I guess I should say f of t here. Equals capital F of s, where capital F was this integral from 0 to infinity. And the statement of the shifting theorem says that basically if you shift your f of s by alpha, f of s minus alpha, that's going to give you this right-hand side here where s is replaced by s minus alpha. And that will be the Laplace of your original f of t times e to the alpha t. Okay, so think about that. How you might prove that, and I'll be back in a second. I've written out a couple steps here. The proof is actually very simple as long as you understand what the Laplace transform is and how it's defined. So we're going to take this original statement here, the given that the Laplace transform of little f is equal to this right-hand side, the improper integral, and just replace s with s minus alpha. So that gives us capital F of s minus alpha, replace the s right here. Just do a little bit of exponent work, and that equals the integral of e to the negative st times this new function here, and that basically replaces our little f. So that's, by definition, that's the Laplace transform of e to the alpha t times f of t, and that's what we had to prove. Here is one example. We have seen that the one-to-one correspondence between our little f of t and our capital F of s here. If little f is the sine of omega t, that corresponds to the omega over s squared plus omega squared. That's our capital F that goes with it. Sorry for my capital F here. So the question would be, if we shift the right-hand side a little bit, replace s with, say, s minus 3, plugged in a 7 there, what little f of t corresponds to it. So there's always this one-to-one correspondence between your function f and its Laplace transform. So going the other direction, if I gave you the Laplace transform here, what would it be? And this is just a simple application of the theorem. We've shifted it by 3, so our alpha is equal to 3. In the setup here, I have that omega is equal to 7. So this one here is going to correspond to e to the 3t, since alpha is 3. And my little f is the sine function. And in this case, omega was 7. So this says if you would integrate this function right here from 0 to infinity, you would get the other side over there. Sorry, integrate this function from 0 to infinity, you would get the right-hand side. Actually, I realize I just said that wrong. This is our capital F. That's what you get if you integrate the little f right here. So integrate this from 0 to infinity, multiplied by e to the negative st. That's what brings in the s, which gives you this side over here.